So we just listed, we talked about method number 1 for finding the LCM. This is method number 2 for finding the least common multiple, which is using prime factorization. And there's some similarities with finding the GCF. So we would start, again, we'll use the same numbers that we used last time, which was 10 and 12. So 10 and 12. We know our answer is going to be 60 because we just did it using the first method, but we'll now do prime factorization. So I'll start with making factor trees. Think of what numbers can I split these into as factors. If it's a prime number, then I circle it because I can't factor anymore. 12 could split into 4 and 3. 3 is prime, so I circle it. And 4 can split into 2 and 2. So now I have their prime factorization. Now here's where it starts to differ from using prime factorization when we were finding the GCF, and that's it. When we write out the factors, we're going to use exponential notation. So if I have 10, I'm going to list that we had 2 times 5. Okay. And then for 12, I had 2 2s, so that's 2 squared, and I put times 3. Now you notice I kind of left a little bit of a gap right here. It's because I want us to really be thinking about the different numbers that we're using. So I used my exponential notation. I've now written out the prime factorization. Now what I'm going to do is I'm going to look at these two lists, these two rows. I'm going to look for numbers that are more than one, or numbers that I have at all. So do I have any 2s? Yes, I have a 2. So I'm going to write a 2 down here. Do I have any 3s? Yes, I have at least one 3. So this is how it's different than GCF, because if you have one of them, then you're going to have to write it down here. And do I have any 5s? Yes, I have a 5. Now for my 2s, I had a 2 and I had a 2 squared. You need to choose the exponent that's the greatest one. So if I have a 2 and a 2 squared, I'm going to put 2 squared down here. If I had a 2 cubed and a 2 to the 4th, I would pick the 2 to the 4th and I would write that down there. If you have a number with an exponent, the biggest exponent of that number is going to go down to match that number. So then now I would multiply 2 squared times 3 times 5. 2 squared, same thing as 4, times 3 times 5. 4 times 3 is 12. 12 times 5 equals 60. So we get the same LCM. But this time we took our two numbers, we listed out all the prime factorization, we looked for what we see in at least one row, any number we see in at least one row, so we had a 2, a 3, and a 5, and then if we had a number in more than one row, we picked the one with the bigger exponent, so this would be 2 squared. You could do this same method if you're working with 3 numbers. So to give an example of this, let's say we had 12, 16, and 36. Now these are much larger numbers, so if we were listing out the multiples, we can see how that might be a little difficult or cumbersome. So I'm going to split these into my prime factorization. Could split into 2 and 8, 2, and 36. 2, 6, 6, 2, 3, and that factors into 2 and 3. So now I'm going to do the same thing. I'm going to list out my factors, my prime factorization. 12. I had 2 2s, so it's going to be 2 to the 2nd power. Again, I'm making sure to include those exponents. For 16, I had 4 2s, so that's 2 to the 4th power. And for 36, I had 2 2s and 2 3s. 2 squared times 3 squared. So now I'm going to look for any number that I have in at least one row. Do I have a 2? Yes, I have a 2. It happens to be in all 3. It's in more than one row. I'm going to choose the one with the largest exponent. So it's 2 to the 4th. So I'm going to write 2 to the 4th down here. Now I'm going to look in the next. Do I have any 3s? Yes, I have a 3. Doesn't matter that it's not in all 3. If it's in at least one, then it counts. In this case, it's in 2 different rows. So I'm going to choose the one with the larger exponent, the greater exponent. It's 3 squared. And then I'm just going to take these numbers. 2 to the 4th times 3 to the 2nd is the same thing as 16 times 9, because 2 to the 4th is 2 times 2 times 2 times 2. 3 squared is 3 times 3. 16 times 9. If I need to do the multiplication over here, that is totally fine. 9, 14, and I would see this equals 144, which happens to be my GCF. So it works with 3 numbers just as easily as it works with 2 numbers. And that's finding the least common multiple using method 2 or prime factorization.